Okay, let's start day 2 with more parabolas. Section 6.1 continued. So we're going to look at more parabolas, right? Writing equation, more parabolas like we did yesterday, and to graph some more parabolas. So the difference being the vertices are going to be at HK as opposed to 0, 0 like they were yesterday. A lot of similarities between yesterday and today. The main ones is that they're still parabolas. So they still have 4 directions, 4 positions. One opens right, one opens left, one opens up, and one opens down. Sorry, you can't see that. I got to move my little box around. The difference now is that the vertex is at HK as opposed to being 0, 0. So yesterday was yesterday was 0, 0. Today is HK. So this is a kind of a summary slide of everything that we are covering. So here's our first example. We're going to write an equation like we did yesterday. The 3 things we need when we're writing an equation are the same as they were yesterday. So we still need our direction, we need our vertex, and we need the p-value. So all the equations, all the problems, excuse me, won't always give you the vertex, but this one does. Our vertex here is 2, 6. So this has changed. Again, yesterday was 0, 0. Now it is 2, 6. There's 2, 6. And then we get our focus at negative 1, 6. There's our focus. So our focus and our vertex. Again, we talked about this yesterday. So the direction now, if the focus is always on the inside of the parabola, the direction is going to be to the left. And the equation, the generic general equation of a parabola that opens left would be this: y minus k quantity squared equals negative 4p times x minus h. So now we have the vertex. We can plug that up. Once we have the direction, we know the general form of the equation, but we don't have our p-value. But again, from yesterday, just like it was and what the definition says, this distance from the vertex to the focus, that is our p-value. And in our case here, this p-value equals 3. So p equals 3. There's our equation. There's our vertex. So we can plug it all in and get an answer of y minus 6 quantity squared equals negative 4 times p is negative 12 times x minus 2. So there's our equation. Again, the difference yesterday. Yesterday was at 0, 0. We didn't need to have the, it was just y squared and just the x. Now we have the new vertex in there. And just again, the vertex is the opposite, negative 2, negative 6 in the equation, positive 2, positive 6 in the. So our next example then, this gets us into everything that we covered yesterday, everything with the graphing and what we're looking for. So there's our equation, same stuff as we've talked about. We want to talk about the direction. We want to talk about the vertex, the axis of symmetry, the focus, and the directrix. Also have the length of the lattice rectum. I'll call it lattice rectum. So let's start with the direction. Just like we did yesterday, we can tell this is x that is squared, so we know it is up or down. And because this 12 is positive, we know it is going to open up. The vertex, that is from here, make sure you always take into consideration what number is by the x, what number is by the y. So this 3 is by the x, that's our h value. It's going to be positive 3, negative 2 is our vertex. Let's go ahead and plot that. There's 3, negative 2. We'll come back to our axis of symmetry here in a second, but we'll look at the focus. So if this opens up, here's the generic form of a parabola that opens up, x minus h quantity squared equals positive 4p y minus k. So for our focus and directrix, we need to find our p-value. From our equation, what is in the place of that 4p? It is 12. So 4p equals 12. Our p-value is going to equal 3. So that tells us from our vertex, I'm going to go up 3 for the focus, 1, 2, 3. And that point is positive 3, positive 1. And I'm going to go down 3 from the vertex for our directrix. And again, that directrix is a line, not a point. So here's our directrix right there. Here's our vertex. Here's our focus. I'm not too concerned about the width or anything. There's what the graph would look like, the parabola would look like. So our equation of this directrix is 1, 2, 3, 4, 5, y equals -5. The lattice rectum length, again from yesterday, is going to be 4 times p. 4 times 3 is 12. Now the axis of symmetry, again, we talked about this yesterday as well. This is always perpendicular to the directrix. So our directrix is y equals something. Our axis of symmetry is going to be x equals something. And it's going to be x equals the x value of the vertex. Vertex is 3, 1. So our axis of symmetry is x equals 3. So our last example then is, I'll be back to that previous slide. Here's our last example. Now we can tell from this that this is going to be a parabola. We can tell that because we only have one squared term. If we had two squared terms, if x was also squared, that was where we got into a different kind of section where it would be a circle. And so we only have one squared term, so we can tell it's going to be a parabola. We can tell this opens left or right because of y is squared. And we can also tell it opens right because the number in front of y is positive. So we can tell all that before we start anything. Going back to this previous example, as we've said all year long, this quantity squared means we have a perfect square. Over here in this last example, we don't have a, this is a squared, but this other y is here also, so this is not a perfect square. And just like we have always done as well, if we don't have a perfect square, we need to complete the square and make a perfect square. So I'm going to do that with the y values. I'm going to kind of combine a couple steps here. We go y squared minus 6y plus a box. I'm going to move this 4x over by adding it. 4x. I'm going to move this 1 to the right by subtracting it. Minus 1 plus a box. And just as we have always done when completing the square, we take our b term, -6 divided by 2 squared equals -3 squared, which equals 9. 9 to the left, 9 to the right. So this now factors. So I'm going to factor that as y minus 3 quantity squared. On the right, I get this, 4x plus positive 8. 4x plus 8. So we're close. I can tell what the y value of the vertex is, but I can't really tell what the x value is. So what you want to do here on the right is always to factor out this number out in front. So my final equation is going to look like this. Y minus 3 squared equals 4 times x plus 2. So there's my equation that I'm working with. And now from here, I'm going to do the same thing we did in the previous example. I'm going to find the vertex, focus, directrix, and everything else. So here's the answers to that last one. We're looking for the vertex, focus, direction, directrix, axis of symmetry, and the length of the lattice rectum. So that's the rest of all the examples for this last section of notes. If you like what you saw, make sure to smash that like button, subscribe, and comment below. And I'll see you Monday.